So in just 3 years, there is a very real statistical probability that your direct supervisor is going to be a piece of software. And if you aren't reporting to an algorithm, you will likely be mentored by one.
Yeah, that is the reality staring us in the face right now.
Right.
The recent Microsoft Workplace survey data is, well, it's pretty wild. 18% of people are actually anticipating an AI boss, and 36% expect an AI mentor.
Wow.
Right. The ground isn't just shifting. The entire, tectonic plate of the global workforce is basically fractured.
Well, welcome to the deep dive. If you are listening to this and feeling a profound sense of whiplash, just wondering what skills actually matter anymore, you are definitely in the right place. Today, we are putting on our seasoned AI and tech consultant hats.
Exactly. Our mission today is to really cut through the noise. We want to deliver a strategic, actionable roadmap for the AI era for you.
Right, we're looking at what mindsets, what specific cognitive skills, and what surprising career paths you, and really the next generation of learners in your life need to target.
And we are pulling the intelligence for this roadmap from a very specific stack of sources. We've got corporate strategy insights from Fujitsu outlining the future of employment, some really fascinating global education data from Forbes.
The Forbes stuff is great.
Yeah, it really is. And we're also looking at hands-on learning frameworks from Tech and Tails, plus the latest digital literacy guidelines published by MEXT, which is the Ministry of Education.
So, figuring out how to navigate this landscape, I think, requires looking at the destination first. Like,
Yeah.
if an adult today is going to be reporting to a digital entity, we need to understand the nuts and bolts of the corporate environment they're walking into.
Yeah, absolutely.
And the Fujitsu report details this massive structural teardown. They're talking about moving from traditional functional hierarchies to what they call work chart organizations.
Right, because the traditional org chart is static. You
Yeah.
sit in a silo, marketing, finance, engineering, whatever, and your value is basically tied to that fixed department.
You're just a box on a page.
Exactly. But the work chart model completely vaporizes those silos. The organization becomes this fluid, decentralized network where teams are rapidly assembled and then disassembled based solely on specific tasks or outcomes.
It kind of makes me picture like a Hollywood movie production.
Oh, that's a good way to look at it.
Yeah, like you bring the lighting crew, the directors, the actors together for the shoot, and the moment the film wraps, the entity dissolves and everyone just moves on to the next entirely different project.
That is the perfect operational model for this.
Yeah.
But the critical evolution in Fujitsu's work chart is who, or I guess what, is actually on that crew. AI agents are no longer just, sophisticated software tools that a human uses to do their job faster.
Right.
They are being officially integrated as digital workers.
Hmm.
Major financial institutions like BNY Mellon and MUFG are actually onboarding AI agents into their HR system.
Which is just mind-blowing. They are assigning them employee IDs, tracking their quarterly output, measuring their error rates, just like they would with a human desk clerk.
Yes, they are literal nodes on the work chart, which, as you can imagine, completely redefines the human's role in that network.
And this is where we really need to dispel the most pervasive myth about the future of work, I think.
The coding myth.
Exactly. The idea that because AI is built on code, the only people who will survive the transition are hardcore software engineers. But Forbes data actually shows that the most explosive growth, and honestly, some of the highest compensation is happening in AI-adjacent roles.
Roles that require absolutely zero coding ability.
Zero.
Yeah, we are seeing massive demand for titles like educational content reviewers making upwards of $42 an hour, or RLHF contributors pulling in almost $50 an hour.
Okay, so for those not living in the machine learning trenches, RLHF stands for Reinforcement Learning from Human Feedback.
Right.
And my understanding of this role is that the AI models can scrape the entire internet to learn vocabulary and syntax, but they don't actually know what a good or helpful answer looks like until a human explicitly shapes its behavior.
Through a reward system. You've hit on the exact mechanism there. Generative AI is essentially a massive probability engine predicting the next word in a sequence. It lacks lived experience, it lacks cultural nuance, and it has no inherent understanding of human context.
Right, it's just doing math.
Exactly.
Yeah.
So an RLHF contributor acts as the loss function for the AI's training.
So they are providing the human friction. Like, if a medical AI generates a treatment summary, a software engineer can't evaluate if the tone is appropriately empathetic for a grieving family.
No, not at all.
You need a human with a background in nursing or maybe social work to review that output, rank it, and tell the algorithm, hey, this response is technically accurate, but it's emotionally tone deaf.
Precisely. The human is injecting domain expertise into the model's weights. The machine generates the raw volume of information, but the AI-adjacent worker provides the editorial judgment, the ethical boundaries, and the strategic direction.
So we are transitioning from a workforce of knowledge generators to a workforce of knowledge editors.
I love that phrasing.
Yes. But let me push back slightly here. If AI is acting as a colleague or even a boss, does that mean our primary job in the future is just babysitting algorithms?
It's a fair question, but it's less about babysitting and more about directing. If our primary value in a work chart organization is providing uniquely human editorial judgment, then rote memorization is officially a dead currency. The real question is how we actually train those editorial muscles in the first place.
Which brings us to education. We've seen frameworks aggressively pivoting away from standard STEM programs into STEAM, injecting that A for arts into the technical curriculum.
Yeah, and the addition of the A is really the critical firewall protecting human capital here. STEM disciplines, science, technology, engineering, math, they're fundamentally built on convergent thinking.
Okay, convergent thinking. Can you unpack that?
Sure. They train the brain to follow a logical, established sequence of rules to arrive at a single correct answer.
Which is exactly the type of processing that AI can execute flawlessly and infinitely faster than we ever could.
Exactly. But the arts demand divergent thinking. The A requires the brain to hold multiple, sometimes contradictory concepts simultaneously, to leap across unrelated disciplines, and to design solutions that prioritize human emotional resonance.
Right.
AI can synthesize a technically perfect piece of code or a mathematically sound architectural blueprint, but divergent thinking is required to determine if that software actually solves a human frustration, or if that building feels welcoming to walk into.
And the data backing up this shift in cognitive training is wild. The research highlighted in Tech and Tales points to a 2024 study where learners engaged in STEAM education saw a 118% boost in creativity.
That's huge.
It is. And a massive 126% increase in complex problem-solving skills compared to traditional frameworks.
Those metrics represent a fundamental rewiring of how a learner approaches ambiguity. And that agility brings us to what the Fujitsu report identifies as the paramount meta skill for this era, learning as a skill, and they couple that tightly with reconnection skills.
Let's unpack the mechanics of reconnection because I found this fascinating. We know technical knowledge has a shrinking half-life. Like, the software platform you master today will probably be obsolete in 3 years.
Oh, at least. Probably sooner.
Right. So unlearning becomes just as critical as learning.
It does. And unlearning is an incredibly resource-intensive cognitive process.
Yeah.
You have spent years building these neural pathways that automatically default to a specific way of executing a task.
Yeah.
Reconnection skill is the ability to actively dismantle those pathways,
Huh.
isolate your core competencies, like your editorial judgment or your divergent problem solving, and dynamically map them onto an entirely new set of market demands.
It reminds me of the psychological friction of remodeling a house while you are still actively living inside it.
Oh, that's a stressful thought. But yes, accurate.
Right. You have to tear down the load-bearing walls of your previous expertise, say your mastery of traditional SEO copywriting, and use the raw materials of your language comprehension to build a new structure, like becoming a prompt engineer for a generative AI.
Exactly.
You aren't changing your fundamental intelligence. You are just dynamically reconnecting it to the current reality of the work chart.
And that dynamic reconnection is what global education ministries are struggling to codify right now, because the integration of AI tools actively works against that cognitive friction.
Yeah, that is the dark side of this technological leap. If we are handing learners or even corporate employees these incredibly powerful optimization engines, the temptation to simply hit, generate, and bypass the cognitive struggle of remodeling the house is just overwhelming.
It's too easy. And this brings us directly to the digital literacy guidelines published by MEXT alongside some corresponding OECD research. They have isolated AI literacy into two foundational pillars: how to ask and how to doubt.
I've looked at those pillars, and how to ask isn't just about typing a command into a text box.
No, not at all.
It is an exercise in systems thinking. You have to mentally map the entire architecture of the problem before you can engineer a prompt sophisticated enough to yield a valuable result.
But the deeper concern, honestly, is what happens when we fail to execute the second pillar, how to doubt. The OECD highlights a very documented neurological danger known as cognitive debt or cognitive offloading.
Cognitive debt. Walk
Uh-huh.
us through the actual mechanism of how that happens in the brain.
So neurologically, learning and critical thinking require struggle. When you have to manually research a topic, synthesize conflicting sources, structure a logical argument, you are building robust synaptic pathways.
Okay.
Cognitive offloading occurs when we use AI to bypass that friction. If the machine instantly provides a polished, synthesized output, the brain doesn't have to do the heavy lifting. Over time, the synaptic pathways responsible for critical analysis begin to literally prune themselves through lack of use. You accumulate cognitive debt.
Wow. It is basically the calculator problem from decades ago, but scaled up to our executive functioning.
Yes, a perfect analogy.
Like, we used to worry that handing a kid a calculator before they grasped long division would prevent them from understanding math. But this is so much deeper. It's not just failing to do the division, it's failing to possess the baseline number sense required to look at the calculator's output and recognize when the answer is completely absurd because you hit a wrong button.
Exactly. And MEXT explicitly warns about this because AI models frequently hallucinate facts. They mathematically amplify societal biases present in their training data.
Right.
So if you have offloaded your critical thinking to the machine, you have no internal compass to detect those hallucinations. You lack the argument sense to realize the AI's flawless grammar is actually masking a deeply flawed, biased logic.
So the ultimate human necessity, the reason we aren't entirely replaced on the work chart, is our ability to act as the final human-centric verification layer. We have to doubt the output.
We do. And MEXT guidelines stress that banning generative AI in educational corporate settings is a losing strategy. I mean, the technology is ubiquitous.
You can't put the genie back in the bottle.
No. The mandate is to teach the friction. We have to train learners to treat AI as a sparring partner that needs to be interrogated, rather than some oracle that just delivers the absolute truth.
The strategy makes sense on a macro level, but applying it at home feels incredibly counterintuitive.
How so?
Well, if the goal is to protect against cognitive debt and prepare a learner for a hyper-digital, AI-saturated future, I feel like the knee-jerk reaction for most people is to force intensive, screen-based coding boot camps starting at age 6.
Yeah, which is exactly what the research from our sources,
Yeah.
specifically drawing on Montessori perspectives adapted for the AI era, explicitly advises against.
Really?
Yes, the foundation for surviving an AI-driven environment is actually heavily reliant on experiences cultivated completely away from screens.
I have to challenge that approach. Recommending that we step away from screens to prepare for an AI future sounds like a nostalgic retreat. Are we really saying that playing in the analog dirt is a viable strategy for competing with algorithms?
It sounds paradoxical, I know, but the mechanism behind it is rock solid. Digital environments, especially those powered by AI, are hyper-optimized to remove friction. They predict your next keystroke, they autocorrect your spelling, they curate your feed to match your preferences.
That's true.
It is a flawless, frictionless feedback loop.
And the real world is the exact opposite of optimized.
Right. The physical world has gravity, it has uneven surfaces, and totally unpredictable variables.
Yeah.
When a learner tries to build a complex structure out of physical blocks on an uneven rug, it collapses.
And they get frustrated.
Exactly. They have to cope with the visceral frustration of that collapse, analyze the physics of the failure, and rebuild. That physical friction is what builds psychological resilience, empathy, and a high tolerance for ambiguity.
Oh, I see the connection now. If a learner's only interaction with problem solving is through a flawless digital interface that never challenges them, their psychological resilience just shatters the moment they enter a fluid, unpredictable work chart corporate environment.
Because there's no clear right answer there.
Right, so you are using the messy analog world to build a fail-safe environment for their neurobiology.
You are inoculating them against the anxiety of failure. Look, AI handles the optimized, frictionless tasks. Humans handle the messy, ambiguous, high-friction problems. You simply cannot train for high friction in a frictionless digital sandbox.
But obviously, we can't ignore the technology indefinitely. Eventually, digital tools have to be introduced without triggering the cognitive offloading we discussed. I've seen some tech educators pushing physical computing using microcontrollers rather than pure screen-based coding platforms.
Yes, and our Tech and Tales source heavily emphasizes this approach. They strongly recommend incorporating accessible microcontrollers like the micro.bit into early learning.
So for context for everyone listening, a micro.bit is a tiny programmable computer board. It costs about 3,300 yen, or roughly 20 bucks.
Very accessible.
Yeah, and it's packed with sensors, LED lights, and inputs, but it has no screen of its own.
The brilliance of the microdot bit is how it bridges that digital-physical divide we were just talking about. A learner writes a simple script on a computer, but the output doesn't happen on a monitor.
It happens in the real world.
Exactly. It happens in their hands. They program the board to physically flash a light, trigger a motor, or sense a change in temperature in the room.
They are establishing a sensory feedback loop. It isn't just passive consumption of an algorithm's output. They are literally pulling the technology out of the screen and forcing it to manipulate the physical world.
Which changes their fundamental relationship with the machine. The goal of introducing a $20 microcontroller isn't to mass-produce software engineers. The goal is to demystify the technology entirely.
To make it less intimidating.
Right. It teaches the learner that AI and computing aren't these magical forces that just happen to them. They are raw materials that can be bent to serve their own creative vision.
It perfectly executes that STEAM framework we talked about earlier. They are leveraging the technology and the engineering to manifest the art. It shifts their mindset from asking, what content can this machine generate for me, to asking, what problem in the real world can I force this tool to solve?
That proactive, manipulative mindset is the ultimate defense against cognitive debt. You remain the driver. The AI remains the engine.
We have mapped out a massive paradigm shift today. The ladder of the traditional corporate hierarchy has been replaced by the fluid network of the work chart, where software holds a permanent seat at the table.
Navigating that network requires abandoning the pursuit of rote knowledge. Instead, we have to aggressively develop our editorial judgment. We have to lean into the divergent thinking trained by the arts to provide the nuance that models intrinsically lack.
Right. We have to actively build the psychological resilience to unlearn our obsolete expertise and reconnect our core human skills to whatever the market demands.
And we have to vigilantly maintain our cognitive pathways by constantly asking the right questions and aggressively doubting the frictionless answers the algorithms hand us.
It's about maintaining the friction that makes us uniquely capable.
Exactly.
So, as you step back into your workflow today, consider the ultimate implication of this technological leap. Throughout this deep dive, we've established that generative AI has effectively commoditized the how.
Yeah, you no longer need to know exactly how to draft the boilerplate code, how to synthesize the 50-page report, or how to structure the complex spreadsheet.
The machine handles the execution.
If the how is essentially free and instantaneous, the true currency of the future economy is the why.
Think about a massive, complex question or a deep intellectual curiosity that you have historically ignored. Maybe it was a passion project or a business concept you abandoned because the sheer mechanics of the how just seemed too dense, too technical, or too time-consuming to execute. If you no longer have to fear the execution, what is stopping you? How could you partner with an AI today to start exploring that why? The old blueprints for the future might be obsolete, but the raw materials have never been more accessible. You just have to decide what you want to build.